Now we're interested in finding out what the equation of a circle is. So again, let's start with a sketch. Let's say we have a circle that has a center at the origin. And it has an unknown radius. We'll just call that radius r. The equation for a circle actually comes from a little bit of geometry because we can create a right triangle from my point on the circle. So let's give that point first a name. Let's give it the name xy, the x value and the y value for that point on the circle. So if we come straight down from that point, we've essentially created a right triangle. Now the base of this triangle is the distance from the origin to the right, how far we traveled to get to that point. That's the x value. And then the height of this triangle is how far we traveled from the x-axis up, which would be the y value. We traveled right x and up y to get to this point on the circle. And you'll notice we have a right triangle and we know all three sides, or we have names for all three sides. And the three sides of a right triangle are related using the Pythagorean theorem. The Pythagorean theorem says 1 leg squared plus the second leg squared will equal the hypotenuse squared. This turns into x squared plus y squared equals r squared for our circle. And that is exactly the equation of a circle if that circle has a center at 0, 0 at the origin. X squared plus y squared equals r squared. Where does it come from? It comes directly from the Pythagorean theorem. Now, we're interested in finding the equation of the circle if the center is not at the origin. So again, let's sketch. So let's say we have a circle and we've shifted it. The center of my circle is no longer at 0, 0. So let's give the center a name. Now that center is not a point on the circle, so I don't want to call that xy. We could give it any other variable name. And the most common one is h, k. So let's call the center of this circle hk. And then let's pick a point on the circle, just like we did before, and we'll call that point on the circle xy. Draw in our radius from the center to that point, and we can label that r. R is the radius of that circle. So we want to know what's the equation for the set of points that creates this circle. The center is at hk. We draw a right triangle again. So from the center, draw your right triangle. And we know if we can figure out the three sides of this triangle, we can use the Pythagorean theorem. So that's really our goal right now. Let's figure out what the base is. So if you go straight down from the center to the x-axis and think about what's the coordinate here? What's this x value? Well, that's just the x value of the center of the circle, which would be h. Then let's do the same thing from the point on the circle. Let's travel straight down to the x-axis. What would that x value be? That's just the x value of the point, xy. So the base of that triangle is just this horizontal distance between x and h. And as we talked about before, we know we can find a horizontal distance by just subtracting x minus h, the larger minus the smaller. Now let's do the exact same thing for the y values. So we want to figure out the height of our triangle. So if you travel from the center and come straight over to the left, we have this unknown y value. Well, that would be the value k of the center. And do the same, travel from the point on the circle straight to the left to the y-axis. That y value would be the y value of your point. So now we're interested in the distance between these 2 points because that'll give us the height of the triangle. And that's going to be y minus k. So if I take what I have here and kind of enlarge it, let's just look at just the triangle itself. Right now, the base of our triangle is x minus h. The height of my triangle is y minus k. And the hypotenuse of this triangle is r, the radius. So now you have all three sides of your triangle, and you can use the Pythagorean theorem to relate all three. That would be the base, which is x minus h, the quantity squared, plus the height of the triangle, which is y minus k, the quantity squared, is equal to the radius squared. So again, I want you to pay close attention to the subtraction in the formula. People often can't remember whether it should be addition, whether it should be subtraction. The subtraction comes from finding that horizontal and vertical distance, the base of the triangle and the height of the triangle. So in summary, we have essentially two equations for a circle. The center at 0, 0 yields the equation x squared plus y squared equals the radius squared. It's just the Pythagorean theorem. And then if you shift the circle to a different center, call that center hk, then your equation is x minus h, the quantity squared, plus y minus k, the quantity squared, is equal to your radius squared. They're essentially the same equation. You don't need to memorize them as two separate equations. It just depends on whether the center is at 0, 0 or your center is at hk. But you can see if I allow h to be 0 and k to be 0, then I have the original equation, x squared plus y squared equals r squared. Quick example just to make sure we understand. So let's say, as an example, I'm interested in the equation for a circle. I would like the center to be at 2, negative 4, and I would like the radius to be 5. Okay, well, we know our equation for a circle is x minus h, the quantity squared, plus y minus k, the quantity squared, equals the radius squared. So we know our h and our k values, 2 and negative 4. So we'd end up with x minus, you can go ahead and put your 2 there, x minus 2, the quantity squared, plus y minus, in this case it's negative 4, the quantity squared, is equal to my radius squared, and my radius is 5 squared. So simplifying gives you your final answer of x minus 2 squared plus y plus 4 squared is equal to 25. That's the equation for a circle with a center at 2, negative 4, and a radius of 5.